Full name, Paul Rascagneres.
Thank you. Yeah, it's working. So, yeah, I will quickly introduce myself. My name is Paul. I'm the malware analyst lead at Volexity, and I'm based in France. I hate reversing modern language like Rust, Go, and this kind of thing. But this topic won't be about anything related to reversing because it's way too early. And I will discuss about blockchain, which is absolutely out of my comfort zone. It's not something I'm supposed to do. And a small disclaimer, you won't be rich after this talk, sorry, if it was what you expected. And I'm really not a blockchain expert, so maybe I will say something which is not 100% accurate. Maybe I will sometimes use the wrong word. So if there is some really good expert on blockchain in the room, I apologize by advance. Why I'm here is because we had to deal with a couple of incidents that are linked to blockchain. And when I say incident, I'm not speaking about how to pay a ransom. I'm not speaking about money itself. I'm speaking about a couple of different threat actors that use blockchain as C2 infrastructure. So that will be the presentation about that. And 1 year ago, I didn't even know how everything was working. So I decided to do something a bit different on the agenda. I will start to explain the blockchain, but like for dummies. That's what I was 1 year ago, to understand what it is, why it's relevant from a TI point of view, and yeah, basically what is Ethereum, what are the smart contracts, how it can be analyzed from an analyst point of view. I will show you a couple of real-life examples, and one of the examples was more or less leaked on Friday by Bandiant. They published something about a North Korean threat actor abusing Ethereum for C2 communication. You will see. And at the end, I will discuss a little bit about the hunting opportunities we have on this specific domain. And the tool I use, basically, it's only it's free tool, so you already have a lot of tools that are designed to track transaction like money, like ransom payment and stuff like that. But the same tool can be used in our context because, in fact, a payment is a transaction, and the attacker are using transaction for C2 communication. But we will see how it works exactly. Why it's matter? It's from an attacker point of view, it's super interesting because it's a decentralized infrastructure, which is almost impossible to take down. And it's already known by threat actor for ransom. For example, most of the time, the victim need to pay in Bitcoin, for example, which use blockchain. It's already used for C2 communication, as we will see. And it's also already used to host payloads. So basically, the malware downloads something from the blockchain, and it's the next stage. So as I said, it's almost impossible to take down because it's legitimate first, and the way it's designed, we will see it's designed to be almost impossible to take down. It's super hard to identify legitimate traffic from malicious traffic because the malicious traffic is exactly the same than the legitimate traffic. It's transaction, it's to read smart contract and stuff like that. So it's almost impossible. And yeah. And yeah, blockchain is legitimate today, so you cannot really block it. So for those who are absolutely not into blockchain, that's basically the design. So you have the blockchain, in this case Ethereum. You have something that is named full node. That's where you have the blockchain. It's where it's hosted. And you have RPC node, which are the node you contact. For example, when you do a transaction, when you buy something, or when you transfer money, or whatever, you contact a RPC node, and after they contact a full node. Some stuff are missing on the graph because, for example, you have archive node, which are an archive of the entire blockchain. And the way you can contact RPC node is by using HTTPS or WebSockets. So that's the two protocols that are supported. That's why it's pretty hard to identify malicious traffic from legitimate traffic because they use exactly the same infrastructure. So that's an overview of the infrastructure. Now we need to speak about smart contracts and what is a smart contract. So simple explanation is it's a software, a program you developed that will run on the blockchain. So you develop something in JavaScript or something that looks like JavaScript. You push it on the blockchain, and it's really like a piece of program that is running on someone else's computer. And you export function. So you develop something and you export like get C2 server. And you're able to query this function, and it computes and give you an answer. It's developed in JavaScript. It's converted in bytecode. And one of the tricky part is each different blockchain has its own bytecode. So if you need a tool to parse the bytecode, you need a tool that works for the blockchain, for example, for Ethereum. And for the major blockchain, we have tools that works more or less. But if it's a really exotic blockchain, we basically doesn't have any tools to analyze the bytecode, and we need to do it really manually. I can show you just to understand a little bit better, because I think it will help. That's the IDE which is used to develop a smart contract. You developed it. It's in the browser. You don't have any client. It's not like Visual Code or you download a client you developed. In this case, you must develop it in your browser. You must have a browser extension where you have your wallet, like MetaMask, for example. So you have your extension, you have your wallet, you have some money on the wallet. You develop the smart contract, and when you want to push it on the blockchain, you generate a transaction. The web page asks to your wallet to pay the transaction. You say yes, and your transaction is pushed on the blockchain. Your code, your program, your smart contract is pushed on the blockchain. And you cannot remove it. Once it's here forever. And that's basically how it works. For me, I'm old, and it's a little bit weird to have money on my browser and an EDI in my browser that push stuff on someone else's computer. So you really don't have anything local. You could do that on your phone, basically. And yeah, that's how it works. A smart contract, that's a design. So it's really like a mini virtual machine. You have the VM. You have some storage. You have persistent storage, so you can put data into your smart contract. You can update the data. And you have two kind of stuff. You can read storage, so read the data. It's free. Everybody can read storage. But if you want to write something in your smart contract, you need to generate a transaction, so you need to pay something. You need to pay a fee. The fee is proportional to the computation that is needed to write and do the stuff. Just to give you an idea, it's few cents. It's really not expensive. It's not always the same price, but it's few cents. Sometimes it's even lower than 1 cent. So the attackers can easily write data on the blockchain. It's not like super expensive. And an infected machine can read the storage. It's free. They don't need to pay anything. And it's really like an operating system. You have a CPU, you have some memory, you have the storage, etc., etc. So that's basically what is a smart contract. And now let's discuss a little bit about few malware that use this technology. The first one I worked on was documented by Sequoia. And in this case, the attackers use smart contract to store directly the command to be executed. So if you look at the Sequoia blog post, you directly see some PowerShell command. So the attackers generate a transaction, push a command into a smart contract into the blockchain, and the infected machine go on the blockchain, check for a specific smart contract, and get the command to be executed. So it was really the easiest way to do. And on Friday, Mandiant released this blog post about a North Korean actor, which is in fact exactly the same than the previous one. It's simply two different campaigns, and they level up a little bit. So in the previous one, you have command to be executed. On the new one, if you take Mandiant graphs, it's basically the infected machine initial downloader on their schema is going on a smart contract, to get something in the storage, and this time it was not a command, but it was base64 encoded and obfuscated JavaScript. So the malware directly downloads JavaScript from the blockchain on a specific smart contract. So how it works, it's you have the downloader has the ID of the smart contract. It's able to go on the blockchain at this specific ID. You have the smart contract, and they can get the next stage, which was JavaScript in this case. There is a couple of other examples that are not documented we work on. Something we name noteful in our case. This time, the smart contract got two exported functions, which is getStrings, setStrings. You can guess the purpose of each one. So the malware was using getStrings to get a strings, and the strings is a C2 server. So to update a C2 server, the attacker simply need to use the setStrings method to set a new C2 server. And the malware will go on it, check, oh, I got a new C2 server, I go on this new C2 server. This way to do is make the shutdown really complicated, because you cannot shut down the blockchain. And even if you shut down or take down the C2 server, they will update it by a new one. The only weakness on this kind of thing is if the attackers has some design weakness on the smart contract. So you need to find a vulnerability or a weakness in the smart contract code. For example, imagine you have the set strings, and I'm able to generate a transaction on set strings to put my own C2 server. And in this case, I could like sinkhole. The thing is, in this case, the developers knows a little bit how it works, and the set strings was limited to a specific wallet, and I don't have this wallet. Only the attackers has this wallet. So if I try to use set strings, it will be from my own wallet, and the malware is designed to download C2 from another wallet on this smart contract. So it doesn't work. I cannot update the C2, and I cannot do any sinkhole, but it's a possibility. That was the design in our case, when you have some executable at the beginning, and this executable noteful in our case was contacting the Ethereum smart contract to retrieve a C2, and this C2 was used to download the next stage, and the next stage was JavaScript. So same thing, it's pretty hard to take down everything, because even if we speak to the hoster and ask for C2 takedown, they simply had to pay 1 cent, and they will have a new C2 by updating the smart contract, generating a new transaction, and that's over. That's basically the smart contract. It's pseudocode. I don't have the code of the smart contract. It's simply by analyzing the bytecode what I think it is. So you can see the set strings. You have C2 on as the first argument. It creates an array where the index is a message sender, so that's the wallet that initiates the transaction, and it's a C2. And getStrings, it basically retrieves the strings array. But as you have the message sender index, and this index is the wallet that emits the transaction, I cannot create a fake one. If I use set strings, I will have a new entry on the array with my own wallet, and that's not what the malware is looking for. So basically, it's really like 6 lines of code. It's pretty easy. We got another one we named PowerStar. This one is linked to what we name Charming Cypress, which is Charming Kitten, so an Iranian threat actor, where this time the attackers are using EPFS to retrieve the C2 server, a little bit like the previous one, but a new blockchain. So EPFS is a peer-to-peer network, which is also a decentralized project. And one of the biggest difficulties we have with all this stuff is each time an attacker chooses a new technology, we have to learn everything from scratch, because the protocol is different, the bytecode is different, everything is different. It's like learning a new language each time, and it's really, really time consuming, and you really have a ton of decentralized storage, peer-to-peer network, and blockchain stuff, which make our life really miserable. That's the example of this specific malware, and you can see on the screenshot that it's downloading directly on this decentralized network the next stage. Another case we work on this time, it's linked to transparent Jasmine, transparent Pride, Pakistan threat actor. And this time, yet another decentralized network that is also a blockchain network, which is named NKN. So same thing. You need to learn a new protocol. You need to understand everything. And most of the time, they don't develop everything from scratch. They use a third-party library that support this decentralized network. But it generates big binary, and you need to identify which part is this third-party library to understand a little bit how everything works. This time it was an easy one that simply provide a reverse shell to the attackers. So, yeah, that's a couple of examples. Only on the last, 12 months, maybe less, 9 months. And we don't dedicate our time to that. So I expect there is a lot of threat actor using blockchain. It's simply this one, we found it on incident or by ourselves, but it was not on purpose. The good thing is we have some threat hunting opportunities with this kind of technology. The first one is, for example, if you have VT and if they don't steal all your money yet, you can search on VT for RPC node, samples that communicate to RPC node. So you will have all the legitimate application because every tool that use blockchain need to contact RPC node, but you can have a first filter, and based on that you can make some whitelist or some heuristic. But yeah, it's something you can do more or less. You can also hunt for third-party libraries that use blockchain. Because if the library is embedded on a binary, probably they use it, probably it's used blockchain. The thing is, even if you have some samples that communicate to the blockchain, you don't know if they are legitimate or not. So you have a lot of manual analysis after to decide if it's malicious or not. And the other thing is the attackers can create its own RPC node and develop the malware to communicate through its own RPC node. And if you don't know it, you cannot search for it. That's an example for Notfall. I simply search for Cloudflare ETH.com, which is a really famous RPC node for Ethereum. And you have a bunch of samples, and all the samples that are with some detection are Notfall in this case. So you can easily find some stuff like that. After, you can monitor transaction. On the blockchain, everything is public. Every transaction are hard-coded and documented. So you could imagine you are looking for transaction that looks like a base64, transaction where the data looks like a P file, for example, or any script. It's something you can do. You can also monitor for URL inside a transaction, for example. It's something that can be possible. And you can even imagine scanning the entire blockchain. Just to give you an idea, the entire blockchain a few weeks ago, it was around 14 terabytes. So it's not that big. It's big, but it's not like crazy big. You can create an archive and do your scanning offline, and it's something that it will take time, but yeah, if you know what you're looking for, it's acceptable. You have some interesting platforms such as Etherscan, SCScan, etc., that allow you simply by a browser to look for transaction and make some search. And yeah, it's a really nice way to visualize. If you have a malware, in the malware you have a smart contract ID. You can go on Etherscan, copy paste the ID, and you will have the smart contract, the bytecode, and you will have all the transaction, the first one that creates the smart contract, but also all the transactions that perform an update, for example. So you can easily identify the wallet linked to the attackers. All these platforms are free. The only limitation is you have more or less one platform by blockchain. So if they are using a really exotic blockchain, you need to find a really exotic explorer. And yeah. To be fair, the first one, for example, support a bunch of different blockchains, the most famous one. But theoretically, you have one explorer for one blockchain. Some other tools that I use that are pretty nice. You have Tenderline. Tenderline, you can simulate transactions. So if you don't have any money and you don't have Bitcoin and you cannot really interact with a real smart contract, you can simulate here. I use it not really because I don't have money, but more I want to test and try. And the problem, if I try on the real smart contract, the transaction appear on the blockchain. So the attackers knows that this wallet is doing something with my smart contract. And sometimes I don't want to do that, but I can simulate, check if I can update, for example, the C2 and how it works. And if I want at the end, I can use it on the real blockchain, but it allows me to debug for free, and simulate transaction. The second one is the decompiler. It's the less worst I found. And yeah, just to give you an idea, the 6th line of JavaScript I show you, it's like 10 pages of assembly, bytecode assembly. So it's really verbose. But it works. One of my favorite tools on the previous presentation, we discussed about Maltego. Arkham Intelligence is the Maltego for the blockchain. So the UI is very nice. You have this entities concept exactly like on Maltego. It's way nicer than Maltego. It's not in Java, it's in the browser, and it's pretty nice. And you can do this kind of stuff when if you have a lot of you have one smart contract, and this smart contract you have a lot of transactions that was done to this smart contract, you can generate bubble like that. So you put all the wallet you want to monitor, all the smart contract you want to monitor, and you can make this kind of graph to visualize a little bit better how everything works. Because it's, imagine you have a wallet that performs transaction to a smart contract. But this wallet is doing also transaction on a bunch of other smart contracts. It's probably linked together, and you probably found some other malicious smart contract you need to check extra, but it can help you to pivot, exactly like Maltego. And initially it's used to follow money. It's used to follow payment. You can see which wallet is paying to which wallet and make some big graph. But you can use it simply to map the infrastructure from an Ethereum point of view of a specific wallet or a specific threat actor. And it works pretty well. It's really, really a nice tool, and it's free. You can use it for free. For example, I create a cluster of all the wallets I think are associated to not fall, and I'm able to do this kind of graph and identify even more smart contract, even if I don't have the sample. And yeah, you cannot guess, for example, the number of infected system, because when you are a malware, you don't write anything on the storage, you don't generate transactions, so you cannot see them on the graph. So what you see is generally really only the attackers. You cannot see any victims, because the way the infected machine communicate to the blockchain, it's a freeway, and you don't generate transactions, so you don't appear in the blockchain. So, conclusion for me, it's already used. I started to look 1 year ago, and I already have 4 different cases, 1 incident. So it's here. It's simply nobody really look at it on this from this point of view. I prepared my slide like last week, and on Friday, Mandiant published his blog post exactly about this topic, and they are covering one of the cases I wanted to share with you. So it's really something that exists today. For me, it was really a completely new world. I had to understand a lot of concepts, like the smart contract, the transaction, and even simply how to pay in Bitcoin to generate a transaction, and how this browser extension works, etc. It was really, really something completely new for me. From an attacker point of view, it's super interesting because in this case, we only see attackers pushing payload, C2 server, or something like that in the blockchain. But we can even imagine attackers running code directly in the blockchain. For the moment, they simply store strings, but they could do way more if they want. The only thing is they have a limitation. They don't want an infected machine to generate transaction because they don't want to pay for each infected machine. They only want to pay to push something inside the blockchain. And it's really a complicated topic, and the Maltego-like stuff I show here, you can really quickly be completely lost because you pivot, and at the end you are completely lost. You have thousands of bubbles, and it doesn't make any sense, and you are pivoting on a market where they buy Bitcoin, for example, and stuff like that. So you need to be a bit careful when you pivot to don't go super far. But yeah, with the presentation, I hope at least you have the basic knowledge of Ethereum. Mathematically, it's really complicated. From a code point of view, it's really complicated, but the global design is not that complicated. It's simply you push smart contract program in the blockchain, someone else's computer, and the attacker is able to store data on this smart contract, and the malware is able for free to retrieve data from a smart contract. That's everything you need to know from a CTI analyst point of view. And after, if you want to do some tracking, I provide you a few really good tools I use for incident and for tracking. And yeah, if you have question, maybe I will have the answer, maybe not, but we can try.
I see a question from Alexander.
Quick questions regarding IPFS. Did you look into IPFS, and especially that knowing a bit IPFS is only a limited set of bootstrap node and entry point? Did you look into that and to find a way to monitor IPFS more closely?
No, as it was only one case, one sample, I didn't spend too much time on it because I had a lot of cases with Ethereum, so I had to dedicate my time on Ethereum. So I don't know for this specific decentralized network.
Can you hear me? Hello?
No.
Sorry. Good talk. Thank you. The RPC nodes, are they not a known endpoint, like DNS names, whatnot?
Yeah, they are known. Basically, when you use a third-party library, they have a bunch of them. That's the famous one. But after, you have a lot of unfamous RPC node, and you can even create your own RPC node and tell the malware to use your own RPC node. If you use your own RPC node, it can be easily blocked by a proxy, for example.
Yep.
But if they use any of these hundreds of famous, well-documented RPC node, if you blacklist them, you blacklist the blockchain, which is maybe used legitimately in your organization. I don't know.
Not on my servers, but yeah, thank you.